Hello everybody, welcome to today's class for Standard 10 Physics. Today we're going to be talking about energy. Now, in our previous classes, we talked about what energy is, its scientific definition, we looked at its equation, and we did a few calculations. Today we're not going to be looking at that side. We're going to be looking at sources of energy and how we convert these sources into usable forms. Now, what are the two types of fuels or two sources of energy? Can you give me a few examples? I'm going to give you a little bit of time to think about it. Now, for those of you who are saying renewables and non-renewables, that is the answer I was looking for. There are two main types, non-renewable and renewable sources of energy. Now, when it comes to non-renewable sources, you can divide into fossil fuels and clean sources of non-renewable energy. Fossil fuels are mainly coal, petroleum and natural gas. So now we all know what coal is. Most of our homes, we use it for making heat. Petroleum is basically petrol, diesel and LPG. So we use petrol and diesel for our cars and bikes. We use LPG for cooking gas at home. Natural gas is like LPG, but it's formed separately from petroleum. It's a better form of gas when compared to LPG. Now, then there's nuclear energy. You'd wonder why this is termed along with non-renewable sources, because you've all heard that nuclear is a clean form of energy. The thing to notice here is non-renewable sources are sources that will get over if you use them for a while. So even though nuclear is a clean source of energy, it's not an unlimited source. It will get over just like the rest of them, and therefore it is non-renewable. Now let's look at renewable sources. These are things that you can use forever without the fear of getting over. Now, the main two that we use currently in renewables are solar energy and wind energy. Now, solar energy, as we know, is the energy coming from the sun. The wind energy is the movement of air, and we harvest the kinetic energy of this moving air to produce energy that is usable for us. Now, the next set is tidal, wave and ocean thermal energy. All these three are associated with the ocean. So we know the ocean tides, the high tide and low tide. We use this difference in height to produce energy, and that is the tidal form of energy. Now, wave energy is when waves reach the shore. So we build a system where we utilize this motion of the waves to create electricity. Now, ocean thermal energy is something that might be confusing for a few of you. So it's a bit more complex than the rest of what we've seen so far. It uses the temperature gradient or temperature difference between the top and the bottom of the ocean, and this temperature difference is used to drive a system that produces energy. Now, next set is the geothermal and biomass energy systems. These two are more niche systems. Biomass is something that you are quite familiar with though. Like in India, biomass is a very important source of energy. We use this in our compost pits at home. Geothermal is using the heat of the inside of the earth. So we've all heard of hot springs. So we use hot springs and the heat from these hot springs to produce electricity. That is what geothermal energy is. So this is one set of renewable sources and this is one set of non-renewable sources. So there's one particular renewable source of energy that stands out from the rest of these, that is hydro energy, basically dams. This has been around since a long time and it's on par with non-renewables when it comes to usability. Let's just look at how energy is produced from a fuel. For example, coal. So we want to know how this fuel is made into a usable form of energy, which is electricity or in some cases mechanical energy. Now, how we go to electricity is we take this fuel, for example coal, we burn it or it undergoes chemical reaction, that is combustion. And when we burn something, what is the first thing that is produced? Well, most of you are thinking heat, and that is what we need. So it also produces smoke and toxins, which are other byproducts that we don't care about right now. We look at the heat being produced by the combustion. We use this heat to evaporate water or any liquid and turn it into steam. Now, we know that water doesn't move that freely, but steam moves very readily. and the motion of this air molecule or gas molecule, that is steam, is used to convert heat energy into mechanical energy. That is, the temperature is used to move the steam, so heat changes to mechanical energy. Now this mechanical energy or motion of steam is used in a turbine plus generator combination. We've already learned what generator does in our earlier chapters. So this generator is used to convert the mechanical energy into electricity. Now, this is the case of something like a coal plant. We can also consider the situation where petrol is used to run our cars. Here, petrol is used and it undergoes combustion, which burns and produces heat energy. Instead of steam, we use gas inside the pistons to convert that into mechanical energy, which gets transferred to the wheels of the car using axles, and that is how a car works. Now let us look at how a coal power plant works. So we've discussed in our earlier slide on how the general fuel is converted into energy. So here coal is taken through into a furnace or a boiler. It is burnt, producing heat. There's water flowing through pipes in this furnace, and as the water reaches this point, the heat of the furnace of the coal burning turns this water into steam. So we know that water evaporates at 100 degrees Celsius and coal burns at much higher temperatures. So the water gets converted to steam, and the steam has a lot of energy associated with it, which is basically heat energy. And since it starts flowing fast, that gets turned into mechanical energy. Now this mechanical energy reaches this place, and there's a turbine that is put there. This turbine starts to spin, and then the spinning turbine is attached to a generator. As we already discussed, a generator moving produces electricity, and this electricity goes out and goes through transmission lines and reaches our homes. So this is how a coal plant converts the chemical energy of coal into electricity that is usable to us in our daily lives. So this diagram might not be as important for you as the concept that is here. So even if you don't focus too much on the diagram, make sure to understand how the chemical energy of coal gets converted into the electricity. Now, let's look at non-renewable fuels and what their benefits and drawbacks are. We're not going into nuclear energy today as it is beyond our scope. We'll just be looking at fossil fuels in this example. So we'll look at the benefits and drawbacks of this. When we talk about the benefits of fossil fuels, the main point is that they are cheap. So fossil fuels are the cheapest available type of fuel in the market. They're also very readily available. So if you know, there are a lot of oil wells off the shore of India. It's there in the Middle East, it's there in the US. There are plenty of coal mines in all across the world as well, and because of that, it is readily available. And even to us, the customer or the end user, we can see that there are petrol pumps like every couple of kilometers apart, and that means it is very readily available to us. And that is a very attractive feature of fossil fuels. Now, they are very easy to use. So we've seen the schematic diagram. All of the systems that are required to convert any type of fossil fuel into usable energy, that is mechanical or electrical energy, or even heat energy in some cases when it comes to water heaters or house heating, these fossil fuels are very easy to use. It all follows one pattern of conversion. Now, advanced technology. What does this mean? Well, we know that coal has been there since the Industrial Revolution. We've been using fossil fuels for a long time now. And it's given humanity a lot of time for science to develop these technologies to a point where they're very robust and we can easily use them without any difficulties. So this advanced technology, there are few bugs in it, and that makes it a hugely attractive prospect when it comes to fossil fuels. But we've discussed all these benefits. Now let's just look at the drawbacks. So these are things that are, first one is quite obvious from the name of non-renewable energy. There's a limited source of these fuels available to us. So as we use these sources, they get over. And if we don't prepare for the future, fossil fuels will be over and we won't have any sources of energy. Now the second and most important point of this is it causes environmental pollution and climate change. From a science point of view, climate change is very true, and it is very visible from most of the climatic events that have happened on Earth recently. If you look at the floods of Kerala, the cyclones that went through West Bengal or Mumbai this year, if you look at the very cold winters that were experienced by countries such as America, where temperatures dropped well below the historic low points, if you look at the extreme droughts that are being caused all across the Middle East, all of these are examples of climate change. So when we burn fossil fuels, they produce gases such as carbon dioxide, carbon monoxide, and sulfur dioxide also produces particulate matter. These components go into the atmosphere and cause the greenhouse effect. We've learned in detail about the greenhouse effect in earlier classes. So burning of fossil fuels produces greenhouse gases which cause greenhouse effect, increasing the temperature of the earth. This causes the earth to have very random climate patterns which cause damage not only to human lives but also to property. Now, the environmental pollution bit is also very important. It makes our lands less usable and is also very dangerous to humans, because inhaling particulate matter or carbon monoxide or sulfur dioxide is very dangerous to humans and animals alike. So these are the drawbacks of fossil fuels, and which is why we have to move away from them and towards renewable energies soon. Now let's look at renewable fuels. We looked at the examples earlier. Let's just talk about the benefits and drawbacks of these for a second. So the benefits of renewable fuels is that, one, they're unlimited source of energy, as is very evident from the title. So why are they all very, very unlimited? If you give it a thought to think about it, you will understand that all renewable energy comes from the sun. You might ask, how is that? Well, we know how winds happen. Wind happens because of difference in temperatures of air, and then the less dense air moves up and the more dense air moves there, or hotter air goes up and cooler air moves down. This is how wind happens. Now, we know that the heating of the earth is from the sun, and that is why wind is due to the sun. Solar energy, obviously, you can understand why it is from the sun. Waves are caused due to the wind, which is also effect of the sun. Ocean thermal, the difference between the top and the bottom of the ocean, is also because of the sun. And plants need energy from the sun to make cause photosynthesis, which is how biomass energy comes in. So all of these energies are derived from the sun. Now, an interesting fact that you guys might find interesting to listen to is that the amount of energy reaching the earth in 1 hour from the sun is more than the energy that the whole of the earth uses in 1 year. So imagine how much of this energy is out there for us to harness. Now, the second point about this is renewable energies are usually very clean and safe for the environment. So energy like wind, solar, or geothermal do not cause any sort of damage to the environment. They also do not cause pollution, and they're also safe for humans. But there are a few drawbacks. Let's look at them as well. So we know that all these benefits exist and fossil fuels are not all that good for us. So why hasn't renewable fuels overtaken the fossil fuel industry and become a commonplace in our daily lives? That's because of these few drawbacks. Even though these are things that we are working on, it will take some time for us to overcome them. The first of which is, it is expensive. We all know that money is the thing that drives the world. So fossil fuels are much cheaper right now than most types of renewable energy. But if we look back 20 years, renewables are even more expensive. Now it's starting to become competitive with fossil fuels. So in a couple more years, we should be able to compete the two with favorable results for renewable energy. Now, but until then, they will still take a second seat to fossil fuels. Second is that technology is still under development. Now, I told you that fossil fuel technology has been existing since centuries ago, where we started using coal, but most renewable technologies have only been existing for maybe a couple of decades, maybe a bit longer, and therefore the technology associated with it and the way we harness these fuels is not perfect. These sources of energies cannot be utilized very well because of the glitches in our technology. Now, the third and probably the most off-putting point about renewable fuels is that they are intermittent. They have a dispatchability issue. Now, this is a confusing point for most people. What does this mean, dispatchability? So let me give you an example. Imagine you have solar panels in your house. When do we get most energy from solar panels? If you're thinking about the sun being in the sky, well, that is the right way to think about it. So whenever you have a high amount of sunlight, that's when you get the most out of a solar panel. And we all know that that is during midday or afternoon time when the sun is the brightest. Now, where are most people when the sun is out? Other than this corona time, most of the day is spent outside the home, probably at school, work, or some other place, and we all end up at home mostly in the evenings. So in the evenings there is no sunlight to produce this electricity. So you see that the demand is during the evening, and we are producing very little during that time, and we produce a lot during the day, but there's very little demand at that time. So most of the energy being produced during the day is getting wasted. Now you might ask, why can't we store this energy and use it in the evening? The reason for we cannot do that right now is that storage is also expensive. So the more expensive it is, the less interest people have in a certain fuel. So now let's look at hydroelectric power plant. I told you in our second slide that this is different from most renewable sources of energy. Now, why is that? This has been around for a long time. It has no dispatchability issues. The technology is almost perfectly developed, and we can do this all without causing global warming, which is a huge advantage. Now, there are plenty of dams all across the world, and let me just tell you how it works. Again, the schematic diagram is not what is important. It is the principle of how energy from the water is converted into electricity. So, we have water at a certain height. We build a dam on a river, and the water goes up to a certain level. Now, in this level of water, we all have learned that due to the gravitational potential energy, there's some energy stored at the height of this water. We also know there's a pressure pushing down due to the atmosphere and also due to the weight of the water. And we have a small strip here where water is allowed to flow. So due to this gravitational potential energy and this pressure due to the atmosphere and due to the weight of the water, it pushes the water out in a very high velocity. Now we know that if there's a velocity, there's a kinetic energy associated with this. So the potential energy is getting transferred into a kinetic energy, which is a mechanical form of energy. Now this mechanical energy or the flowing water turns the turbine. This turbine is associated with the generator, and as we discussed earlier, this generator can produce electricity when there's motion. Now this electricity is transferred to our homes and the water flows down the river. This is a very dispatchable form of electricity. You switch on a tap or open this gate and suddenly you already have electricity. So this is how we are currently coping with our fossil fuels to renewables disparity. But one thing about hydroelectric power plants is that it is not as good as solar or wind energy, purely for the fact that a lot of people have to be displaced to build a dam. There's a lot of dangers associated with building dams, such as flooding or dam breakage. There's also the problem where the soil underneath the dam gets damaged and it becomes unusable for the future. It also causes damage to the wildlife associated with the dam. So these are problems with hydroelectric power, but until we are able to use solar or wind energy very successfully and remove the problems of technology and dispatchability, we are probably heading in this direction when it comes to using renewable energy. I hope you enjoyed today's class. We'll be coming back soon with more discussions on solar and wind energy. Thank you.